So welcome everyone to our seminar series at the University of San Francisco. The seminar series is sponsored by the Data Institute. The Data Institute is the umbrella organization of all things data science at the University of San Francisco. And let's use this guy. Thank you. Our speakers today are Pardhu Gunnam and Prithvi Nuthanakalva from Metaphor Data. Pardhu is the CEO and the co-founder of Metaphor Data, and Prithvi is the ML engineer and MSDS alumni from the last cohort. Okay, great. Today they're going to talk about AI's impact on modernizing data catalogs. Can we give them a round of applause?
Thanks, Victor, for the introduction, and good afternoon, everyone. Last year, our company also presented Marsland, my co-founder presented a talk about metadata. I don't know how many of you got a chance to it. Oh, it's not. How are you? We call this the Microsoft way, like we start everything. So I was just saying that, referring to the talk from Marsland, my CTO, co-founder, about the basis of metadata and what is a metadata platform and why is it essential. So this talk, we want to cover some of those basics, but also want to take it one step ahead and talk to you about how we are leveraging AI to kind of like take the game to the next level. So let me I want to do a quick introduction to myself. As I said, like I'm CEO and co-founder of Metaphor Data. We are working on a modern metadata platform right now. And in the past, I have also worked and created Data Hub, which is an open source, very popular open source metadata platform as well. It's quite adopted across the industry. And before that, I was at LinkedIn, AWS, Amazon, working on data platforms. And I still want to refer myself as an engineer as often as I could, but I do a lot of sales calls, so I cannot completely say. And before that, I did my master's in UFL University for Internet Physics. How many of you have seen this picture? At least I see some nods. Great, thank you. The only thing I didn't like about this picture was it didn't include LinkedIn, which is one of the most popular data companies. But just to quote what is in there, right? Like the world's most valuable resource is no longer oil. Okay, this is not new. Like now it's quite familiar for like everyone what is data and like what is the data roles and things. Back like 10 years ago and things, like it's not common. Like when I started as a data platform, joined LinkedIn as a data platform engineer, I had to explain to many people what does that role mean, right? Like why people know software engineers, people know IT engineers, but data is like, it's kind of like known to everyone, but like why do they need a special role for called data platforms and what is that role? So as the picture signifies, right? Like what you see are the most pioneering technology companies, and which in the last 2 decades, if you can think about it, one thing these are the most popular companies which really revolutionized the industry. And one thing that is common across all these companies, if you see like great products, great business models, etc., all these things, if you keep these things aside, one thing that's really common among them is actually the data. So data existed for a long time, right? Like, and people always use data for doing various things, but these companies took it to the next level in terms of how they make all the data connected and like get maximum value out of the data. If you think about what data's applications were like a decade ago or so, it's really like the tip of the iceberg. Right? The real value of the data started coming out when it's connected across the company, and like every single decision started becoming a data decision. So the most popular trend in the last decade or so, it's continuing, is actually digitalization or the data democratization trend, which is happening across not just the tech companies, non-tech companies, every single sector. So it's also reflected in terms of like the roles and the jobs which get created. Data jobs are one of the most popular sorted out things, which I think I don't have to explain to this group. So CDOs are like one of the most rising executive roles that got created across all the companies in the last 5 years as well. So, enough about the data. So my talk is not really just about the data, right? It's actually about metadata. So I want to bring in the connection between the data and the metadata. Why is it important? And metadata is also like a little bit of a common term, but there is so much of depth in terms of like what that really means and how is that, why is it like really powering like a lot of innovation in using data itself. And my favorite movie, one of my favorite movies, though I say I don't want to talk about data, I cannot explain metadata without referring to data, right? Like, so metadata is data about other data. It seems trivial, but like let's get into the talk and then help you understand what kind of things qualify as metadata and what doesn't, like, and why is it very much connected to the data itself. This is a simple example of an Excel sheet or like a Google sheet. Like you can see what you can see from the table, like bunch of numbers, and there is no special thing other than on the first row, other than it's bold, and we all know by convention that that signifies something, right? Like this actually is talking about what the rest of the column is about, etc. as well. But in simplicity, yes. This is like a bunch of numbers or a bunch of dates. You can understand some conventions are there, some conventions are not there. There's something called null. So for an average user, like if they don't even know what is a null, but in data and technology, they understand. Questions that come around it, right? Like so, if someone tells you that, hey, what do you know about this data? Like other than what you're seeing these numbers, questions which come beyond that, right? If this is representing certain metric or if it is representing some value in your company, right? Questions would come around like, when was this last updated? What is this representing? Of course, it's representing, let's say, a bunch of IDs which got registered into this, let's say, seminar, like student IDs, etc. But like, when was this last updated? What is it representing? Like, how fresh up this data was? Who created this? Is this directly coming from the application? Or is this created by one of the engineers, or like to kind of like download it from somewhere and like created and uploaded it? Or what does this exact each column mean? Of course, there is ID, there is name, but is this name? Is it like? But it also says somewhere like months. Why are months represented? Why like some of them are just happen to be coincidentally names of the people, or if they don't have the name, they just put the month in which it is being registered. Like many questions might come up. Where does this data come from? Most importantly, what we call in technical terms is the word lineage, if you have heard about it. Tracing where the data actually came from is such an important thing, right? Like if someone says, hey, this is, what's the revenue of like your company, right? If you say, 50 million, are you telling it based on the gut feel, or like you heard it somewhere in the presentation, or is it like a projection, or are you looking at actual sales growth and telling you that this is the revenue of the company? So it is quite important to understand across the data, where is the data actually coming from? And last couple of last things, what is this value? How is this value computed, right? Like if someone is coming and giving you a value, like let's say something like significance of this person or the significance of this like application, etc. How is this being computed? Why are you giving a score of 4 versus 0? Score of 3 versus like null? What does even null mean? Right? All these questions come up and need to be answered. And in general term, like beyond the data, what you're seeing in this table itself, all these questions can be answered through metadata. What we call metadata is the data about the data itself. So beyond, like, of course, in real life, when you are actually working with companies, as some of you are familiar with, the data is way, way complex and like a large scale. The Excel sheets which you're talking about, like, are representing the tables in data warehouses or data lakes. They go like 200 columns with like millions of rows, and representing sometimes like multiple millions of transactions, etc., etc. Right? So just imagine, just to give you a scale of like the tables and things, some of these tables go into like beyond gigabytes for 1 day of transactions. Think about visas, like number of transactions that happen per day. If it puts into a table, like how big that table is going to be, because it has to go through each and every transactions. So there are different types of metadata as well, right? Like if you go a little bit deeper, technical metadata, usually like this is representing just the source of it, which is like what the data is about, right? This is coming from the actual data systems. You can consider like various types of data systems, right? You are familiar with data warehouses, you're familiar with data lakes, like where you store the data, operational systems, etc. But there are also dashboards, or if you're familiar with BI systems like Tableau or Power BI, and these all represent like the different like visualizations of the data. All these things are data aspects, right? Like all the data metadata which comes from these systems is all considered technical. And when we connect it through, like from where the data is flowing from one system to another system, that's all called lineage. And we also look at how it is being flowing, when is the data flowing, how is it flowing, etc., along with profiling. This is something which you are very familiar, like not just looking at the table, but like understanding the data, right? How many of these, how is the distribution of the data, what is the maximum value, what is the minimum value, what's the standard deviation. All these things are quite essential for like understanding doing the data analytics on this. Then comes the business metadata, right? So why does data exist? Why is it really created in this company, or like why everyone is trying to do this? It's always about business. If there is no business use case for the data, there is no point in creating the data. So the data is expensive, right? Just people are not capturing the data and like computing all these metrics just for the sake of it. Everything gets started with actually a business case. When you go into the jobs and you start working with different data science or data engineering roles, everything comes with a PM asking, a product manager asking for like a new feature or like a new analysis, or a VP asking for how we are doing, predicting something, whether this is a useful investment for a company or not. So everything is driven by business. But business doesn't talk in terms of technical terms. Business talks in terms of business terms, right? So we're talking about a business metric in terms of profit, loss, or feature adoption, customer retention. All these things are typical examples of your business metrics. So we also need to understand not just the data, what is being created, but why is it created and where is it being used, etc. In the last, and one of my favorite metadata is actually, yes, we created it, we know why we created it, but who and how and where is it being exactly used, which is involving people, right? Like in terms of people and systems, which systems are querying it, who is querying it, how often are they querying it. You can create like 1,000 tables inside a company, and maybe only 10 of them are being used on a daily basis. Other 990 are just being supported. Or 500 of them are like just staying there for never being used in the last 2 years, and just for compliance sakes, people have just created it. So a lot of these questions, right? And if you have questions, if you have answers around, I have a question about, if you need answers around why you made this decision, why you dropped this data, why are you not using, what's the difference between one table versus the other. A lot of this information lies with people itself, right? Like why don't they create data? So these people are often called owners or subject matter experts, etc. So we need to understand the behavioral aspects of metadata as well. And conversations, like for example, once you create the data, you will have like a lot of questions about each single row, each single tape, column, etc. Where to use it, where not to use it. All of these conversations lie inside your Slack or Teams, these kind of like conversations, or emails, etc. So all this, not just how people usually typically think about data is what lies in your actual data systems, but all the what around data encompassing like your conversations, business reports, decisions, etc. Everything is considered actually metadata. So this all drives a lot of value in using the data itself. In a company, like we talked about like all the depth, the different types of metadata, etc. But who cares, right? Why is it important? Who is going to get benefit from it? Data consumers, this is very obvious. You're creating the data for some people to use it, especially with the business, like including data analysts, data science people, business users, everyone who is just like trying to use the data existing data inside the company. But they often have like a lot of questions, right? Like what kind of data? First of all, if you always want to start from the scratch, you will end up you will have like two sets of problems, right? Whenever you go to the raw data all the time and start from the scratch, there are two sets of problems. One, you can completely be inconsistent with what rest of the group is talking about and start computing your own definitions on things which is completely misaligned with the rest of the organization. And second thing, you're not really leveraging the work of others. Someone has already computed what is an active user. Someone has already computed what is the average return rate for an active customer, etc. You want to build on top of that and build your analysis, etc. by leveraging what is already available. So it's quite important for people to understand what data already exists, what analysis exists inside the company, and build on top of it as well. Then the data team, typically the data engineering people or what we call as producers and things, these are the people who are really building the pipelines. How much familiar are you with like data engineering processes and things? I see definitely some parts. So these people usually are enablers, right? Like they are creating the platforms without really understanding why or like how the data is exactly being used. They take the request and like and create these platforms and things and stuff, and the data kind of flows through the system. So they are more interested in syncing the data from like different systems, enabling the processing, making sure the data is up to date and processed right and like communicated, etc. Right? So these people have like very less understanding of the actual data itself, but the data processes and things they're quite familiar. So they do a lot of support time, right, in terms of like making sure, hey, you have John has asked for a new table, and where am I with the creation? Like, and if there is a failure, how do I communicate to them? Or if they have a question about John has created something, but Smith has asked a question around, oh, why is this table not producing this particular column, etc. How do I respond to this? I don't have all the information with me. I need to keep redirecting to John and connect John and Smith to kind of like work together. And then as heads of data or the data leaders inside the company, you are investing a lot of money into the data infrastructure and the data systems. In fact, like one of the top budgets in most of the companies after the marketing and sales spend is actually the data infrastructure itself. And you need to make sure that you are getting actual ROI, return of investment, on top of all these data investments, right? You want a lot of collaboration between the people, a lot of leverage, and you want the data and results to be consistent. End of the day, if the business is not actually able to kind of make the right decisions right time, then your data systems, whatever you build and things are a failure. But why is this really hard, right? Like in a company which is a technology company and things like data exists in systems, why is this answering these questions, why is it really hard? I will talk about not all the problems, but at a very high level about just like thinking about the sheer scale and what is happening in the industry. I'll talk to you about very high level problems, why we see these different things very hard. Finding data itself is very hard. If you consider, if you're familiar with the word like data lake, like everyone wants to kind of like create this one place where all the data goes and lives. But there's also a famous saying, data lake soon, without like proper control, turns into a data swamp. And that's where actually data goes to die. Because imagine you have like millions of tables or thousands of tables, and then you don't know which one to exactly use, which one to trust, which one to build on top of it. Then what good use is that set of tables what you have? And siloed teams represent like siloed data as well. A lot of people are trying to operate at the same time. Marketing is doing their own stuff. Customer success is doing their own stuff. Sales is doing their own stuff, like using the same data and like building like siloed like artifacts and things and stuff. These will not never, they cannot never collaborate on these things or also make it consistent across all these decisions. So how do you help them collaborate easily and understand like each other's data without very much trouble? And why a lot of specialized systems, if you heard about, there is so much of work happening in AI There's so much of work happening in like real-time applications of the data, etc. You go to a website, you want to give like as many real-time insights as possible when the person is on the website and the application itself, right? Like it's not an offline report you compute, you don't have like multiple days to send them insights. So the more faster, the more accurate, the more revenue. Like that's a more adoption. Yeah, that's how it's considered. So with all these specialized systems, there is a lot of specialized data itself that is getting created. So you need to handle all these things. So finding the data, what you're looking for, it's not a problem of not finding any data. You find too many answers, and you need to figure out which is the right one for you. Trusting data is hard. When we say this it's a very connected problem as well, right? If someone asks like, hey, which is the best place to eat here, I might get like 20 answers, like if I ask like 10 people. So it's that way. Like it all depends, right? Like it depends upon where is that question coming from, right? How are they telling that answer? Is it based on the last 6 months? Is this based on like some health report? Is this based on your classroom survey, etc.? It all depends upon the trust, like what you have, like where is the data coming from, like what's the source of the system. Data quality and health are generally referred to as how fresh this data is and how much you can trust this data, etc. It's a funny thing I noticed when I connected to the Wi-Fi. There is a notice going on that if your Tableau dashboards are down, there is an issue going on, and please wait for like a resolution or something from the service now, which is USF dashboards. So this is quite often what we see in actual industry. Like you are relying on data. If the dashboards are completely down, it's easy, right? You know that data is not available, you cannot make a decision. But what if the dashboards are available, but the data is like not being refreshed? How do you know that you cannot actually trust this data, what you're looking at, and you have to wait for making the decision until it's complete? So building this trust and giving this data profile and distribution, all these things, like as the data kind of grew, it became a lot more complex and like cumbersome to kind of compute this trust as like a one single number, like in one single, you cannot just say that this is better than the other, etc. It depends upon what you are asking for and what you are trying to prove for. The last but not least, but the managing data itself is hard, right? Have you heard about the terms like data governance and compliance? Heard about GDPR, which is very much in the news all the time. So this is all the privacy laws which the governments are coming with, especially one of the most popular one was GDPR, right? Like which really haunted many data companies in the last 5 to 10 years, including like some good enough scars from those days as well. So just to give you a scale of like impact of these things, any company who fails to comply with this GDPR laws, like first of all, they have to pay like huge fines to operate in Europe, which is typically like 4% of your entire revenue. Just to give an example, if LinkedIn's data is like not compliant, LinkedIn, including its parent organization, have to pay like 4% of it, which is Microsoft's 100 billion revenue, like 4 billion revenue fine. Right? So that's the significance of like this compliance laws. Like, so you cannot. It's not just data is powerful, but at the same time it has to be well governed and well controlled, and everything has to comply to the privacy and like all the other compliance laws. And impact analysis, like if you have great, like everyone in the company is a data player, and everyone is gonna be like a data scientist or a data analyst, like engaged with some data role. But if there are so many people involved, the communication and the impact analysis of like who is going to get affected, how do you communicate right in the time, and etc. is also extremely complex. Just like the funny thing is, we were talking about sending Slack messages and emails to everyone. The more the severe the issue, we started like adding more red banners and things on top of it, like 1 red banner, 2 red banners, and 3 red banners, depending upon the severity, right? So just like you receive Amber alerts and things, we were trying to push like, hey, this is going to break your dashboards, and if you don't take action and things. We send like 10 of them, 6 months down the line, someone still come back and say that, oh, I didn't see this, and I still like made a wrong decision, and you are responsible for this. data, like why we have to do a postmortem and make sure this stuff. So understanding and communicating the impact analysis is very, very critical in managing with so many people. So, how do we do that? All right. I want to little bit speed up here just to give Prithvi also a bit of time to talk about exciting things. This is all the base metadata stuff. So we actually build like a lot of applications on top of data, right? Like the typical things which you see, like data documentation, data compliance, cost management, understanding which data is being expensive, which is not, which we can like retrieve and reduce the cost, end-to-end lineage. All these applications can be built with the base of a metadata platform. So what we essentially do, we take all the metadata from the systems, from your business processes, and understand who is using it, what, etc. All this information, enrich into the metadata platform to build the applications on top of this. So this is what we call it as actually connecting back to the original slide. If data is the new oil, then metadata platform is the actual refinery which produces the valuable output out of the data. Just to give an example, like we connecting back to the different types of metadata which we build, we all ingest into metadata platform like Metaphor, and it's also important how you distribute this information, right? Of course, there's a web app where you can do nice UI, search like an typical cataloging, such like in terms of how you find products on Amazon, on Yelp, like you need to treat data sets or data products in the same way. If you're not familiar, treating data as a product is so much significance that that is all tied to like how people build contracts with the data and how they kind of like understand the data as a valuable product inside the company. And I talked to you about the Slack and Teams conversations all around data. Everything has to be enriched with this metadata. We need to push all the important information there. At the same time, if you heard about the terms like tribal knowledge or institutional knowledge within the companies, which is every day-to-day decisions around the data, how do you capture that information and like use that for like better enrichment and data processing as well. And we have also looked at like the example of browser extensions, like for example, the Tableau servers being down or the data being down, should it be on Wi-Fi, like on ServiceNow page as a banner, or should it be in actual, when you go to Tableau dashboard, you see that information then and there itself, that there is an issue happening, or there is a data issue happening, or there is a change coming up, heads up, all these kind of things should be like pushed to a browser solution. And the last thing is, it's a platform. It has to be API driven, and everything has to be programmatically able to update as well as like retrieve. So all the data which we collect, metadata, etc., we don't just like power up our applications and our search and discovery, but also power up like any new applications around data, right? Like for example, you'll be working with not so happy terms, but like in terms of requesting accesses or deletion of the data, like Jira tickets, etc. When you go into the jobs, all these processes have to be tied together with the data. And it can be like a lot of automation that can come out of the using metadata itself and APIs. So with that, I talked to you like just to connect it, like we talked about what is a metadata platform and why is it important in the course of a company. Later part of the talk, we want to focus on like, of course, we collect and automate and things and stuff, but how do we does this have to be like manual, or like how do we leverage AI to kind of like really change the game here? So with that, I'll invite Prithvi.
Hi, good afternoon everyone. Thanks for joining. My name is Prithvi. I'm currently working as a machine learning engineer at Metaphor Data. I used to be part of the previous MSDS cohort, and for my practicum, I worked at Metaphor on problems similar to what we'll be talking about today. So in this section of the talk, we'd like to focus on using AI to solve some of the problems that we've seen with metadata platforms. Many of you may have interacted with some sort of a language model in one form or another, like ChatGPT or any other language model. and you kind of appreciate how powerful they can be to write code or to summarize things. So how are we using those language models in like an actual production environment or in a company setting? So I'd like to talk about like 3 use cases, specifically dealing with metadata and how language models can actually make a metadata platform much more powerful. And also at the end, I kind of briefly want to talk about like the architecture that we use to build out these use cases. So before we get into that discussion, I kind of briefly want to give this picture out to explain at a high level how we actually gather metadata. Right? Pardhu talked a little bit about what is metadata and the ecosystem as a whole, but how do we go ahead and capture that metadata in a company database, in a company's data ecosystem? So we have what are called crawlers. These are basically Python scripts that are running periodically that go into various parts of your data ecosystem or your data warehouses where the actual data resides. Periodically, they parse them, grab all the metadata, and package them in a nice format so that users who are using this data can actually gain valuable insights out of it. Like for example, here we have a table. We have metadata around the table, like what is the table about, who are like the owners of this table, or what are the different columns associated with it, how is this table related to other databases in your system, things like that. So the first AI use case that I'd like to talk about is it's to do with descriptions, right? So crawlers go to your data platform, they grab all the metadata information, put it on a nice page that you can visualize, but there is something more that you can do around it. You can attach context to it. Say, I'll give you a simple example. Say you have a table called orders, right? A data engineer is working on it. He sets up this metadata platform. You have a page around orders. Someone who is outside the data system, he comes and visits this page, looks at orders, doesn't have much context around it. What orders are we talking about? Is it to do with a certain product? Is it orders from a certain geographical location? So typically how people do this is subject matter experts are people who are very familiar with certain kinds of databases. They manually go in and add manual descriptions to a particular, the metadata associated with a particular table. Like say orders from a particular geographic location, this is how we compute, this is like the SQL query that we use to access this database, things like that. And this is a pretty manual process, and when you think about it, like in the entire data ecosystem, if you have like 10,000 databases, it's not practical to expect all of them to be manually annotated. And this is where we think AI can be really helpful. There's a lot of context attached to attached with the metadata, so you know what data it is, you know where it's coming from, you know the relationship between this table and other tables in your ecosystem. You pass on all this information to a language model, and in most cases it's able to generate a highly meaningful description that you're able to use as a starting point for annotating your data. Obviously, this is not fully foolproof. There may become some company-specific details that you still want to annotate to your metadata, but at least it acts like a good starting point where you can start off with AI-generated description, then add more details as you see fit. So this is one thing that we think we've added on to our platform, and we think has been really beneficial to get more coverage in terms of adding descriptions to all your metadata pages. So the second use case that I'd like to talk about today is to do with knowledge bootstrapping. So there is a term called institutional knowledge or tribal knowledge, where people in the company, when they talk to their other colleagues, so say when you start a new job at a company, right? You're working in a data team, you talk to your colleagues on how to do certain things. How do I access this? What is this table about? And you have these conversations on Slack and Teams, and you finally get what you're looking for, but ultimately none of this gets recorded. Most of it is not documented. It's kind of left where it is on Slack or Teams. This is where, again, language models can be pretty helpful. So once you've reached a resolution to your question or the thing that you're looking for, language models can help you summarize whatever has happened so far. Say, if it's an issue, you have a nice description of what the issue is, what the resolution is, and then you can automatically document all that information as part of your metadata as well. So one of the features that we have is right where your discussions are happening on Slack and Teams, you are able to summarize or gather like the really important details from your conversation and then tag it back to your metadata base. So one fun fact here is the feature that you're seeing here was actually built by one of the interns who was part of the project last year at Metadata. So the feature is right now in production and is being used by customers as well. So the last use case that I'd like to talk about is natural language search. Right? So the previous two use cases that we talked about are dealing with how do you enrich our metadata. So you have crawlers, they are getting in some data, and you use AI to kind of enrich those data with descriptions, with knowledge bootstrapping. You've kind of got to a place where you have very rich metadata. Now, having rich metadata in your system is not really beneficial unless you make it accessible to as many people in the company as possible. And these people may be outside your data teams. They may be business users who are non-technical in nature, who may sometimes be intimidated by the platform itself, how to operate this, how do I get the information that I'm looking for. So we want to be able to make it as accessible as possible. We want to make it as simple as talking to another data engineer in the company to get the information that you're looking for. So one of the things that we have is what we call natural language search. Most of you might be familiar with the interface. You ask a question to the system, it generates a nice little answer to you, so that you don't have to deal with advanced search operators to kind of go into the platform and get the information that you're looking for. It kind of drastically lowers the learning curve of using a platform. Once you have such an interface, it's basically easy to use. So I'd like to dive into this piece of it a little bit more, kind of get to see like the architecture of what we do or how we build the natural language search search system. So basically, building such a search system involves two parts, right? Building any kind of search system kind of involves two parts. One is your indexing stage, where you kind of ingest all the data that you have in your system and package it into a format that is easily searchable. And then you have like the actual search stage where you get a query from the user and then you try to get back with search results. So we can briefly talk about like the indexing stage. Essentially, what is involved in building like a natural language search system? You want to be able to capture all the information that you have in your system and then put it into a format which is easily searchable. One thing that's different in natural language search is what is the format that you put into it. And this is where the concept of embeddings is quite helpful. So if you're not familiar with like the concept of embeddings, basically you can think of it as a mapping between a piece of text and a set of numbers. So embeddings are essentially a set of numbers that capture the meaning of a piece of text. So you have a large language model that's able to take in a piece of text and output a bunch of numbers which actually capture the essence. So in the indexing stage, you kind of capture all the information that you have in your system, break it down into pieces, and then for each piece of text, you create an embedding. which is just a vector of numbers, and store that in a vector database. So now comes like the search stage, right? Where we're talking about where the user is actually entering a search query and is expecting to get back like a meaningful result on what he's looking for. So when this happens, when the user enters a search query, what's really happening is we are doing like the embedding process again. So we are kind of building an embedding around the search query and comparing it against the vector database that we've built in our indexing stage. So once you have a search query, I have a simple example here. What is revenue? So the user is asking a simple question. We are using a large language model to kind of convert that piece of text into an embedding. We have a vector database that we've created in our indexing stage. We have a vector from the search query. We then do like a nearest neighbor search to kind of find all the different pieces of document that are close or the nearest neighbors for this particular vector. Why is this helpful, right? So the concept with the beauty of embeddings is when you have two pieces of text that are similar in meaning, you expect the embedding model to generate vectors that are actually pretty close to each other. So if you create a vector for what is revenue and try to find all the documents that are close to it in the vector space, what you are likely going to get back is all the documents related to revenue. In this case, you can see it's a toy example, but you would likely get back something related to sales, finance, or balance sheet. And how this is helpful is now you have context around it to answer the user's question, right? So you have the question from the user. How do you best answer that? You have context around it. You then use another language model, say sort of like ChatGPT or any other model. You have the question, you pass in the context as well. Ask the language model, okay, the user wants to know this. These are the documents which will likely contain the answer that the user is looking for. How about you take a stab at it and answer the question that the user is asking for? And hopefully you'll get back a meaningful answer saying revenue is this and this. So at a high level, this is kind of like the architecture that we've been using to build out our natural language search system. LangChain is like the framework that we are building this around. It's kind of like a neat wrapper kind of a framework where, you know, as far as the app is concerned, it's directly talking to LangChain. So if you kind of want to move around or replace the other parts of your stack with other language models, it's pretty easy to do so. So that is at a high level what we wanted to talk about. Before I wrap up, just wanted to note that we are looking for a couple of interns, and you will be working on problems similar to this. So if you're interested, hopefully we'll see a couple of interns. Thank you.
For the Q&A section, please line up on either side so that we can capture the questions for the camera or afterwards, so for the recording. Can you picture that on, Jay? Perfect.
From the last slide, what would be a context, like what are some contexts that would go with that kind of question?
It kind of depends on what information you have as part of your indexing pipeline, right? Say you, for example, the metadata platform that we have, you are indexing everything that you have in your database. So say there are like 10,000 databases, right? Each has a description associated with it. So these are all pieces of text. You convert those into embeddings, store them in your vector database. When you ask a question like what is revenue, hopefully what you're getting back is some documents that are talking about revenue. So in this case, like I said, sales would be something that's kind of similar to revenue. or finance table or a balance sheet would be something similar to revenue. So these are all the documents that you're getting back as part of your nearest neighbor search. So once you have that, hopefully one of those documents will contain the answer that you're looking for. Obviously, this is like you can tune this to kind of improve performance. Like right now, I'm just showing you a case where the nearest neighbor search would return like 3 possible documents. You can tune it to get it like 10 or so that you have more context and more chance of finding the right piece of information to answer the user's question.
Just to add to that, depends, like I said, example, depends who is asking, when they're asking. Like for example, if someone is saying, what's wrong with revenue, or like, what is revenue kind of a thing, depends, right? Like if you're a salesperson who's asking it, then you might be interested in sales related dashboards. Or if you are a data engineer who is asking it, or an exec who is like a VP asking it, what's revenue, then you're looking at official like documentation or dashboards. So there is so much of information going around, like what's recently happening. You are asking about revenue because maybe there is a data issue going on which everyone is complaining about the revenue dashboards, and you want to highlight about that service no request or something like that. So you have a lot of information, but like looking where are you coming from and what is happening right now, that's the context.
Hi, I have 2 questions. First of all, on the indexing side, have you experimented at all with the size of the document that's being indexed and the kind of the size of the vector that you're encoding? The second question is, for the RAG that sending to the LLM, or rather the response getting back from the LLM, do you ever see like hallucinations or kind of things added? This being an issue with especially definitions, where data definitions can get extremely precise of like the user has done this action at this point after these things, and then that is the definition of activated. That seems to, with hallucinations and LLMs, it seems to like there might be some issues there. Have you seen any of that?
So to your first question on the size of the document, that is something that we are currently actively working on. What we've noticed is like if you have like too large of a document and try to embed that, the smaller nuances or the smaller details in the document tend to get lost. So having like, how do you chunk your document, right? So if you have metadata about a table, how do you chunk it appropriately so that during the retrieval stage you get the right information? There's no straightforward answer to that. It depends on like the application that you're building out. We've had some success with trying out different strategies, like you embed the entire document, but also embed parts of the document separately. So for a single document, not just have a single vector, but multiple vectors for a single document, so that you have greatest chance of success of getting back the thing that you're looking for. To your second question on hallucination, because we are restricting the language model to only look at context that we've provided it, so you can do prompt engineering around it to kind of restrict the context to only pieces of text that I provide. Don't try to be smart and answer with your general knowledge. Look at only what you have. If you don't know the answer, just say so. So we've had success with that kind of prompt engineering to kind of prevent hallucinations. So so far it's been good. We haven't seen any cases where it's gone wild rang to some things that are unrelated. Thanks.
So I have a question about natural language search. So let's say after the client side, they ask the questions, then how do you they get the answer they want? Like how do you improve the search?
That's where the kind of like the vector search becomes very helpful. You're trying to find what is the best piece of context, which can help answer the user's question. So you have like a large vector database, right? Each is referring to a piece of text. And the idea is because the embedding space is designed in such a way that all the pieces of text that are similar or semantically related tend to be close to each other in the embedding space. If you do a nearest neighbor search, the closest documents tend to be the ones that are related to the question. So you can use that context to answer. In some cases, like if you ask a question that isn't present in the vector database, obviously you're not going to get meaningful results. But if it is related, the things tend to match with the vector search.
So, like, is there a system that we can get a feedback from the client? Like, oh, are you having the answer?
Yeah, there are systems. We are also actually in the process of implementing one. Is kind of like a feedback loop on. Obviously, you never know with these systems. This is not like a supervised learning problem, right? You don't know if it's a wrong or right answer. So you rely on manual things. There are also actually these are all pretty new. Some things that have come up in the last couple of weeks. Things called RAG evaluation frameworks, which you can build a corpus of questions that kind of are similar in nature to what the actual users might ask, and then you evaluate a system on how well the system is doing on those back of questions. So there are a few libraries, actually open source libraries, that are actually dealing with this situation. It's a quite novel problem. A lot of people in this field working on this.
I have a couple of questions. So for the step 2, are you actually using ChatGPT or like looking at your own language models? Because like someday, like ChatGPT decides for example this point is much more than.
Right now, we are using OpenAI models. We do have plans to kind of fine-tune our own versions of it, specifically mainly because some of the data that we have is like very company-specific. So, but so far the performance, I can't complain. It's been pretty good so far. But yeah, at this moment, it's all OpenAI models.
And also for number 2, when you put in a sentence, then you're getting a vector. So let's say you have 2 sentences, S1 and S2, and you're getting 2 vectors. And do you always get the vectors in the same dimension?
Yeah, the dimension is fixed. So most of the language models, which kind of most of the embedding-based language models, it depends from model to model. But for a single model, if you, irrespective of what size of text that you put in, the output vector shape would be constant. So it would be the same for any piece of text.
Thank you.
Hi, I have a question regarding confidentiality. Like an employee cannot access all data in a database. So how do you tune in any way when asking a query to the system? Are you collecting, let's say, my metadata as an employee in order to tune the response? Okay, you are asking about something that is out of bounds of your confidentiality level, so I'm going to answer you like a general question, a general answer, or is it something that you already do? Or?
Not currently, but it's pretty easy to actually add on in the sense that because when we do like the search, we are doing a search against the vector database. It's pretty straightforward to restrict your search to only a subset of that vector database. Depending upon the employee level, you can restrict your search to only to the subset of that, so that the answers returned do not include any confidential information. But as of today, we don't have that.
Just to add to that, just to clarify, this is only metadata, right? So we don't actually show you the data. For example, you cannot go and say, show me the salaries of my colleagues. So that's, I know that's the first thing people get research. So you cannot do that. We don't store any actual data itself or the actual, like, for example, you cannot say what's the last quarter's results versus this quarter. You cannot ask those kind of data specific questions. we ourselves, to be compliant and secure, we don't even have access to those things. So we just make sure it is data. So you can ask like, where is the salary data located? It is, but you don't have access to the data itself.
Thank you very much.
Hi, first, thank you so much for the presentation. That was very insightful. Second, I was wondering, how does your platform resolve data discrepancies across data sources?
Can you repeat the last part? Discrepancies.
Yeah, how does your platform resolve data discrepancies across data sources? So, for example, I might envision a scenario where I have some data discrepancy across my two data sources between different data assets. So I was wondering, how does your platform resolve these discrepancies?
Great question. So we try to show there are a wide range of discrepancies. Like for example, like in terms of data quality, for example, something is being updated on a daily basis, but it is not, then we can know that whether it is actually there or not. But let's say if certain data is missing, like nulls, we can flag that as expected every day there are like only 50, like there's 10% nulls, but today it is 20% nulls and things like that. This is all like, usually it's called like the data observability space, right? We do limited stuff, we don't do deep into it. What we essentially do is bring clarity to the problem, like where is the problem happening and like what is that we are seeing and like how it is connected together. So we can give you all the results, like in terms of information around what's the two sources, what's the comparison between the schemas and things, when it changed, when it got updated and all. But we don't do too much of like, oh, this is absolutely wrong versus that's the correct one. It's a pretty, the discrepancy detection or anomaly detection and things and stuff is a very deep domain by itself. Yeah. Good question.
Awesome, thank you.
So one of the barriers to entry for ChatGPT for companies can be the pricing. And so I'm kind of wondering if you can give us tips and tricks for how you are able to keep costs feasible or low when using ChatGPT.
A couple of things that we are exploring is caching user questions. So if there is, so you say you've got a search query and you get back search results, we cache that in like a separate database. So whenever similar questions come in, we don't have to run through the whole process. We can kind of reference those results back. But apart from that, it's
All right, non-technical answer. We pass on the cost to VCs.
Thank you.
I have two questions regarding the system design. One, are the embeddings being updated in batch? So for example, are all new Slack messages being embedded and then being sent to the document database? Or are you processing them at the end of the day, and then on the next day people can find the new documents?
It does happen in kind of real time. So whenever there is a change to your source database, that when we are indexing, we are kind of building the vector database. So if there are changes to the source information, we do immediately update the embedding of the vector database so that whatever is in the database is actually the most accurate information.
And my second question was, is the retrieval part of the system, is that just based on vector search nearest neighbor, or are you also relying on the metadata of the documents themselves? Are you storing that in a separate database? Are you utilizing that?
It is the same database, and we are relying on the metadata as well to. So this is like a simplistic overview. There are more nuances to it. So depending upon the type of question, we may want to restrict our vector search to only certain parts of or certain vectors. So and how you achieve that is using like these metadata filters. You filter on metadata and then run the search on only a subset of the vectors.
Okay.
I have two questions. One is, how long does it usually take to initialize the vector database for a like let's say new customer?
Depends on like the size of the metadata that we have for the customer, but it's usually pretty quick for like I don't know if I can give out numbers, but it's not of the order of like hours. It's on the order of minutes.
That's pretty fast. Second question is, with AI, it's garbage in, garbage out. So let's say someone gives some misinformation on Slack about the data that they were explaining. Like, how do you deal with that issue? Like, do you guys have do you give the customers any ways or tools to, scrub that out of their database?
That's a great question, actually. Not just on AI, like it's just on garbage in, garbage out, right? It's pretty true. So the way we there's a saying like, if you have 1 million data sets, like usually like tens of thousands of metrics, at any point of time, only 20% of them are actually used. Most of them are like supportive or garbage metrics and garbage shit, really creative, right? So there are multiple ways to tackle this problem. One is through some kind of certification, in the sense, whatever, let's say your VP says or the salesperson says what's the revenue, CRO says revenue is different than what a data engineer says, and like the definition is like varied in terms of where is it coming from. And there is also some, it's sort of a typical governance process is around data and metadata itself. There is some governing in terms of like, is this approved or not classified? Like, for example, is this gold tag versus like, is it just development tag and things and stuff? Like, there are multiple mechanisms to kind of classify it and then certify it to kind of manage it. Same thing goes in our thing, like number of times someone is actually attesting. There are social signals, like how many people are actually liking and what do you call like, approving this information. All these things like they trust.
Makes sense. Thanks.
I actually had a question on the step 3, which is your searching algorithm. Do you have like a multi-model architecture to figure out which algorithm is giving you the optimized results? Because this is unsupervised learning, right? So how do you assess the results of the algorithm?
So evaluation of the system is like still a fresh problem, not just with us but across the industry. There are a few evaluation frameworks that are in place where, as I said earlier, you have like a question bank, pass it through the system, have another language model take a second look at what answers the system is coming up with, and try to evaluate this is good, this is not good. It doesn't happen in real time, unfortunately. It's something that you do while you're building a building system. But yeah, it's still a very fresh problem that the university is working on.
Thank you.
My question is about natural language search, and I think the system is like quite complex. So the skill set would be we need very different skill sets, like not only the LLM or large language model, and in general we need also skill like how to manage database and then how to make it real time. And so what do you think expect us to do focus on when we do the practical? Is it more data engineering part or
I would say basics of natural language processing would be really helpful. Most of the components that you see here are kind of readily available to say, LangChain is a framework that makes it very easy to build out most of this. A lot of the stuff that goes into making it differentiating your search engine versus others is things like how do you do chunking. Like one of the questions that we answered earlier is how do you chunk your documents, right? If you have like a 2-page document, do you build a single vector out of it, or you build like 10 vectors out of it? It's just I would say mostly basics of natural language processing would be really beneficial. How do you do tokenization? What are things involved there? The rest of the things like building out a vector database and stuff are actually, to be honest, pretty simple. Once you kind of get into the project, you'll figure things out.
Hi, I have two questions. The first one is about the platform. So let's say you have multiple users acting on the same database. What if there's conflict between these two users? How do you resolve this problem?
So you're talking about the metadata platform. So,
Yeah.
like, of course, everything is kind of like, at the end of the day, it's a transactional thing. Like, so there are sessions on things we kind of like identify that, hey, these are the two things which came up, like, and not to get into too much of technical detail, but like we can identify that it's the same object being modified in this from two different places. So with one of them, like based on transaction time and things, we can tell them that, hey, can you please revise this, or the state has changed.
My second question is about just this model, and what if a user has typing a question that let's see, does he got a counter, like he doesn't want, or he thinks it's wrong, and he's retyping the same question, but as from this model, he will always get the wrong answer. Like how to break this loop?
There are a couple of ways you can, so especially when you're dealing with language models, there is something called temperature that typical language models provide. What this parameter does is it kind of varies the output. So if you put in the same question again, say you set the temperature to 0, what you're telling the language model to do is reduce the variable. Try to be as constant as possible. So if you put in the same question twice, you get back the same answer twice. There are ways around tuning that as well. Like if you increase the temperature, you're likely to get different answers. But that also kind of opens up like a can of worms. You don't want the language model to start hallucinating.
Thank you.
So you have mentioned that you do some kind of a prompt engineering to limit the language model to.
Can you repeat it?
Okay, I'm audible. So you mentioned that you can do some kind of a prompt engineering to limit the access completely to the data. Similarly, for different search queries, expectations or the final answers expectations might be different. So for search queries, one type we might expect one word answer or single line answer or multiple lines answer. So similarly, like for each of the case, there might be a requirement of different prompt templates. So in your case, did you write like multiple prompt templates, and if you have written, like how do you map the user search query to the prompt template and pass it to the line chain?
We haven't done it, but there are ways around it. It becomes like a multi-stage process where you first use the user's query, pass it on to your language model, try to grab as much information as possible around what the user is asking, and then the actual process itself, you kind of tune around that. So people are experimenting with a lot of different methodologies here. Obviously, there's a lot of delay attached to it if you make it like a multiple process, because you need to call the language model 2 times instead of once. But yeah, there is work around that as well. People are trying those options.
And one more question is like for the search query and the final answer. For some portion of the metadata, we need like a precise answer, and for some portions of the metadata, we might need like explicit or generated answer. Like, so how is the current state? Like, is it more explainable or it's like precise to the point?
It goes to the same your previous question. If you want to improve your search engine to take it to the next level, you'd have to kind of incorporate the 2-stage approach, where like the first stage you're trying to break down the question, what is he asking, what would be like the kind of the best response? Is it like a single answer? Where should I start go looking for? The vector database is like large, right? If you can get some information from your first, from the question itself on where to search, that kind of limits the scope a little bit more and gives you a chance of getting better accurate information. But again, it increases like the complexity of your system, especially it becomes much more complex when it's like a multi-turn conversation. If you get back the answer, then user poses another question, you do 2 stages again, it kind of messes things up a lot. So, but yeah, a lot of projects are actually trying that out as well, the 2-stage approach. Thank you.
Thank you so much for your presentation. I have 3 questions. The first question is, as you shared that all the products coming from business demand, but I'm still a bit confused about the problems that we are gonna solve here. Is that true that our product is gonna sell to B2B companies so that they can embed the product into their internal cash system, and we're gonna try to solve manual questions over and over again? Is that true?
It's a great question. So it's a B2B product, right? In the sense, this is not just to clarify, this is not a general shared data application, right? This is not public. This is all the questions around people are asking are about that company's data, right? So this is a B2B product, and we use a general language, natural language stuff, like LLM stuff, but it's the questions, answers are all tailored to their company's metadata, and we don't do anything else.
So all the data that you use to train the model is from the internal itself, right?
Yes. From the
internal data from that company itself.
Yes. So the natural language processing part is what the LLM brings, right? The power of the LLM to understand like how to break this sentence and map it to things, but the actual solutions that is mapping to their own data. Like for example, if someone asks like, where can I find revenue data? You don't say on the internet where can you find it. It is about their company.
Okay. The second question is, I saw under our pitch sheet, there's no much information about the projects. So could you please share more information about projects that our students gonna like solve in our 9-month internship?
Okay. So you talk.
More details about the projects that we're gonna solve.
So yeah, I'll talk to Marsh who presented those things and send like more details as necessary. We have more details. we have high level understanding of the projects as well. Like as you say, so many of these questions coming around are all like seeds into the next set of projects which we're working on. And I'm smiling sometimes because this is like someone asked like, hey, how do you build a feedback loop? This is what my customers are. Simple answer is if you don't have it, you're not.
Okay, so is that mean that we're gonna come up with an idea how to solve the problems and then work with you guys to build that model?
It's more, it's not about ideas like what you have and we have, it's actually what the customer is driving most of the things right now. With them. They come with a problem and then we have to come with an innovative solution to take it further. So you will work with us and there is a couple of directions in which we want to solve it. So how we solve, there's a lot of independence on how you solve it and the organization.
So as I understand that it will depend on the customer needs that we're going to solve their problems, right?
Yeah, in specific example, the next 2 set of projects and things which we proposed is based on the last few discussions with the customers and what we decided. So those projects are fixed for the next 6 months or something.
Okay, so clear, thank you. I have another question that because you said on the requirement that it requires more than 2 years experience in coding, but I believe that this part is so interesting that many students are interested in, but they don't have experience, me as well. So what is our chance here to get into this project?
I'll give you the most easiest answer. Depends. So there are many factors which is true, like we cannot just, I wish I have a GPT kind of solution to say like is this a person or not, but it cannot. So I take like multiple solutions and large and take a look into it. Experience, like if it is usually like we go with the most general expectations in terms of make you successful in the project. But if there are exceptions, that is not hard and much. But if you don't have years experience, but like you have some other relevant skill or things which you think is more successful, you can totally apply for that.
So it's experience is like preferred, not must, right?
You can pull that on.
Okay, thank you so much.
Thank you for the presentation. I have two questions that are somehow related to each other. So imagine your model is actually groomed on a huge data that I don't know, you got from some company. So now the model is smart enough to answer certain questions. How this platform can help a company which does not really have internal documentation yet, like a startup company or something? And secondly, how this trained smart model actually is going to filter out some important information from company 1 and do not start answering to company 2, regardless of those prompt engineering that you are assigned.
To your first question, the search is entirely restricted to the company's database. So if there is no information, internal information for a particular company, the quality is not going to be great because we are not relying on like generic world knowledge to answer a question. We are simply relying on the company's database to answer questions. So the better the quality of the data that you have in your system, the better the quality of the search engine is going to be. To your second question on how do we like make sure we do have separate database instances for each company. So when you're getting a search query from one company, the search is only going to occur against its own database. The vector databases are isolated. So you don't have one company's data mixing together.
Alright, so the model is smart enough to already know, because of it has the knowledge from multiple companies, and it can still answer certain questions.
So the model itself is, I assume you're referring to the language model which is actually generating the answers. The model itself is not really trained on the company data. We are only providing it context as part of the search query. So when there's a new search query, we do a search against the vector database. We provide it context, use these pieces of information to answer the question that the customer or the user is asking. So it's not really trained on any particular data. It's just off-the-shelf models that we're using.
I have a question on the search query part. I believe you will be accessing the data directly from Slack or Teams, right? There is a chance of personal identity being part of the information that is sent out as a request to the OpenAI outside internet model. So is it handled by the metaphor, or it's PI is something done at the source?
So good question. So just to clarify, we are not sending anything to OpenAI. Like it's actually customers are like extremely careful about not using OpenAI's model because like OpenAI has also responded that we stop training on your customer data and things and stuff. Like only things available on the internet. To be more specific, this is actually what you're seeing is Azure, like Azure OpenAI, which prevents gives you that isolation and it doesn't let you crisscross across customers and try agents. Second thing, it's not that we automatically scan and everything and then try to do it. Like there's some responsibility on people how what they try to put into it and get information. So it's not like somebody is randomly talking about like actual next revenue numbers or like acquisitions and things and stuff that we don't automatically track them. So there is some kind of level of
With respect to engineering part, when how did you decide the embedding size? I believe MongoDB has a document size limit, right? So within no time you will be reaching that limit for the index. So how do you manage?
It's not huge, to be honest. The current model that we are using is like the vector size is around 1500. So any piece of text you could convert it to a vector of 1500 which it's not really a huge increase in size.
So each embedding is saved as a document. You mentioned about the feedback loop. So your customers are data science data teams. So the pool is less.
For customers are everyone. So even business people who are
Thank you.
Hi, thanks for the presentation. First question, so you mentioned that one kind of cost reduction strategy was caching outputs that before they're sent back to users, so with future similar queries respond the same way. Given the kind of edge case that your context changes, documentation updates, schemas that are changed, whatever it is, how do you check that cache query for validity, even though it might at present out of date, but previously was valid?
It's a really good question. That's one thing that we are still exploring. We still haven't kind of deep into like the caching mechanism. But yeah, that is one big challenge of caching. Maybe there's like a time to live parameter that we have on like the cache, things like that.
Sorry, one more question was, when you are reading in and parsing Slack conversations and team conversations, these can get, in my experience, very complicated and arbitrary. And part of that large effective document size is you're losing nuance where one answer might have been correct, but 100 in the conversation. Is there a way that you have your, I guess, company's users flag the answer as one does in like Stack Overflow or something like that?
Not currently. No, I don't think we have it.
So just one is flagging that's an aspect. Just to clarify, like your question as well, right? So adoption from most of these AI features are like very, very advanced and very cutting edge, I think, right? People have like not yet completely realized, like in terms of like cost and things and stuff, like the general projections and stuff. They're still like being worried about like what it can summarize and things and stuff. Like next comes around how do I optimize it and like how do we improve the consistency and things and stuff. So this is still like yet to be done more, right? Like and amount of data, first of all, like how you don't like I said, you don't automatically pull everything and like make everything. Most of it will be garbage considering like a lot of random conversations, right? So we try to like bring in some level of governance in terms of like, hey, do you want to push this information to us and things and you consider this is important for the thing, or is this some random discussion after like an all hands meeting and things which you don't really care about? So there is an aspect of human in the loop to some extent, and it's not completely.
Thanks.
Okay, so I noticed we have a sea of questions today, but we are going to have to stop here.